Welcome everyone. Thanks for joining us today for this short video. We're talking about recent research that we've done and for which we won the PRISMA award. The PRISMA is Performance and Policy Research and Sustainability Measurement and Assessment, and we won an award about circular economy. PRISMA is based at the Technical University of Dresden in Germany and also co-hosted by the United Nations University. We were quite honored to actually know that our research has been attributed with this award, and the title of the paper for which we won the award is on the screen in front of you. My name is André Stephan.
And I'm Aristide Athanassiadis, and in this presentation we'll explain what is the circular economy in the construction sector and how our contribution could help us foster it and implement it faster. So let's start with why do we focus on the construction sector and why it's so important to apply a circular economy on it. First of all, the construction sector is a huge driver of resource use and environmental impacts. One important fact is that the extraction rates of construction materials over the last century exploded to 50-fold. So, and this was mainly due to urbanization, building infrastructure, building cities. And while this number might seem out of context, well, you have to think that because we're building cities, we are now extracting more and more materials that are harming the environmental ecosystems, but also produce a huge amount of waste. In cities, this is almost a third of materials that come in and that go out as waste. Now, why circular economy? It's because we could reuse cities as mines, and instead of extracting virgin raw materials, we could use those cities as secondary mines to satisfy our future needs of construction materials. Now, let me explain what was the case study where we based our study on. That was the city of Melbourne, which is around 36 square kilometers, and we modeled a big chunk of the buildings of the city of Melbourne, which was approximately 13,000. So you can see here on the map all of the buildings that were modeled and the different building typologies that we took into account. Some of them were a bit too complex to take into account or too small, so this is why they were not modeled. So we took the CLUE database, the census land use and employment database, and we, in order to create some building typologies, we looked at different land uses. So there were 30 and we summarized it to 8. We also looked at different construction periods. So we looked at up to 7 different construction periods, and lastly, different heights. So we look up to 3 different heights for these type of building typologies that you see here in the middle. So all in all, this combination created 48 archetypes, which are what we call a building typology that is quite unique. And for each of these archetypes, we said, well, the material composition, but also this is what the windows look like, this is what the roofing looks like, and these are the materials that are included in the roofing. So what was very unique in our assessment and in our model is that each singular building, not only we knew where it was located on the map, so thanks to the GIS, but it was also modeled parametrically. So on the fly, we modeled each and every single one of these buildings, and we knew exactly how many doors, how many windows, how many walls we had, and what were the windows within those walls, and what were the materials within those windows, etc., etc. So it's a very granular model that we were able to produce. The results of this modeling and in this assessment are these types of maps. These maps are, let's start with the beginning. It's a material stock map, so the one that you see at the bottom right. So this is a quantity map of Melbourne, how much the city of Melbourne weighs. And the additional contribution that we had is to include the environmental embodied requirements of this material stock. So how much energy, how much greenhouse gas emissions, how much water is used or produced in order to put this material stock into Melbourne. So if we had to rebuild the whole city, how much energy, how much greenhouse gas emissions, how much water, how much materials would we use? So this is great. And now we're we try to summarize this into this small infographic. So for 1 square kilometer, for the city of Melbourne to be rebuilt, you would need approximately 1.5 billion kilograms, 10 million gigajoules. In terms of water, that would be approximately 18 million cubic meters of water, and finally 605 million kilogram of CO2 equivalent. So all of this is for 1 square kilometer. And remember, the city of Melbourne is 36.2. So when we go to resilient resource use cities, you always need to remember that there is no such zero carbon or zero material city. There is a huge impact of our cities. So this was done as an overview of the entire city, but you can zoom in per material, per concrete, per steel, per plasterboard, per carpet, and see how much there was. Because of our fine-grained modeling, we could have these type of maps. And we could even go like how many windows you have in the entire city, how many doors you have. We are very flexible with what we can show. In summary, you can see that this type of modeling is very interesting because we can also add a temporal element to it. And because all of these materials do not have the same lifespan, so for instance, concrete lasts much longer than plasterboard or carpet, you can also start thinking about, okay, when will certain materials appear as future waste or future resources? And because we can map these insights, we kind of know how does the city perform as a metabolism and how much it churns in and out materials. This is the core of what this study developed. So you can see an overview of all of these maps. And now André is going to present to you what happens if we explore a bit more the temporal side of these maps.
All right, thanks Aristide for that presentation. And I'll take it from here. So what I wanted to talk about quickly is this particular data visualizations that we tried to put together. So once we finished the study, we were a bit stuck with the amount of data and information that we had on our hands. And we had to be a little bit creative with how we need to actually get the message across. So what we did here is that we borrowed this visualization from population studies. That's an age pyramid. You're typically used to see this broken down into male and female, and the ages on the vertical axis. In here, it's the same. It's an age pyramid of materials. So on the left side, you have concrete, which weighs alone 20 times more than all other materials combined. And on the right side, you have all the other materials stacked together. On the vertical axis is the age of that particular material in the city. Now, what does it show us? It shows us obviously distribution, how old is each material, where is it? It shows us that particular materials such as carpet and plasterboard, like Aristide was mentioning before, enter and exit the stock at a much faster metabolic rates than other materials. And what we also see is particular spikes in the pyramid. And this is really interesting because these spikes, when we dug into the data, were actually due to major construction activities, for example, hospitals or stadiums or significant buildings. And these present particular opportunities for circular economy and urban mining because they are concentrated in one site. So the logistics of collecting materials is much simpler than having to deal with multiple owners and trying to collect a little bit from different places. Now, what I'd like you to look at here and how to perceive this age pyramid is actually to look at it as a table of contents of your inventory of materials, of your material stock. So you can actually, for example, click on this little bit of plasterboard here that is going to exit the stock in 4 years. And we can actually display a map of where is this plasterboard actually situated in the city and how much there is in each building and when it's going to exit. And this level of granularity that Aristide just mentioned before can greatly facilitate decision-making. You can imagine the interest of someone who collects plasterboard as a job in having such maps over time. And this is kind of the power behind the model. Now, we want to just put it up front that there is a lot of uncertainty in such modeling. And there might be other ways of representing this, such as rolling averages over different years and so on. But this is more about the conceptual framework and what kind of information can actually be extracted. So this is really our table of contents. So if I want to summarize quickly what we were doing here, we can actually produce maps of different quantities of materials and environmental flows across the city. And that really is the core of the contribution and typically how this can help inform urban mining in the future and how we can transition, like Aristide mentioned, from extracting raw materials from the far-flung edges of the world in Chile and Australia, depending where you live, of course, and actually moving this mining activity to cities themselves and trying to collect all of these materials to facilitate a circular economy. Now, this all sounds really good, and let's do it now, but unfortunately, we're not really ready yet. So this research is just one of the many things that needs to be done, and a lot more needs to be done, so we can actually facilitate decision-making and make sure that there is actual market value and demand and other things that are needed to go and start mining cities. So the first thing that really needs to be done in the future is improve the visualization of data, because it's so data intensive and it's very hard to digest at first glance. So we need to push this and kind of create single dashboards that summarize all of this as online tools, but not static dashboards, dynamic dashboards that also allow testing particular scenarios and investigating material outcomes and circular economy strategies. We can also see how this model can easily be extended. So we talked about materials and embodied environmental flows and requirements, but we can add other environmental indicators such as the planetary boundaries framework or material criticality and map this on the city. We can also see how we could implement financial indicators such as the value of actually extracting or collecting these materials. And quick warning, this is dummy data, right? We didn't do this study. We can also see how these particular circular economy strategies could produce jobs. Again, this is dummy data, but we're just trying to showcase what could be possible and how much this could empower decision-making. Lastly, we want to emphasize that we didn't model infrastructure, and we think that there is a lot of potential in actually mining infrastructure, notably because it tends to be quite systematic and it tends to be publicly owned, which kind of facilitates the whole process quite a lot. And there's lots of research to be done in this sense. So to wrap it up today, we just want to thank you again for your attention. But before you go, we'd like you to check this particular website and the exciting news that we have to share with you. It's materialstocks.org, which is an online platform that Aristide and I, in collaboration with Metabolism of Cities, are trying to put together. And the idea is to create a centralized repository to put in all the data for material stocks in cities. But it doesn't act just as a repository. And the most value it has is actually its power to streamline data visualization consistently across different cities, allowing comparison, insights in terms of decision-making, insight in terms of the impact of particular policies or scenarios that particular cities have adopted or want to adopt. And so we're very excited to share this with you. This is the first public announcement of such platform, and we're looking forward to the many good things that will come out of it. Thanks a lot for listening, and don't forget to check the link below.
Thanks a lot, and make sure to contact us at this address if you have any questions. Cheers.